Today I will be doing addition theorem of probability. So let us begin with some preliminaries. Union and intersection of events. Suppose A and B are any two events, then A union B. This is pronounced as A union B, means happening of A or B. So whenever you find or between two events, then it means the event is A union B, and it means that at least one of A or B happens. At least one event happens that is called union. And this symbol, if A and B are in two events, then this symbol A intersection B means A and B, means both A and B occurs. So or means union and means intersection. So these are the two main preliminaries. For example, what is union and intersection? See, if A is 2, 3, 4, 5, B is 1, 3, 5, 7, 9, then A union B means the events of A and B, all the numbers of A and B. 2, 3, 4, 5. Then from B you see 1, 3. 3 is already there, so I won't repeat writing 3. So omitting 3. Similarly, 5 is also already there in A, so 5 is also not rewritten. So 1, 7 and 9. Thus A union B means 1, 2, 3, 4, 5, 7, 9. And A intersection B means the common elements of A and B. What are the common elements? 3 and 5. So this is A intersection B. Got it? Now let us come to addition theorem of probability. If A and B are any two events defined on a sample space S, then the probability of happening of at least one of A or B is given by probability A union B equal to probability of A plus probability of B minus probability of A intersection B. See, here also it is given happening of at least one event. So whenever you will get in question at least one among between two event occurs, then that means you have to use this addition theorem. Okay, and A union B means this event which I have explained earlier. A means the event A, probability of B means the probability of event B, and A intersection B means the probability of common elements of A and B. Got it? So let us see one example. Two dice are rolled once. Find the probability of getting an even number on the first dice or a total of 8. Got it? So here, see, there are two events. One is an even number on the first dice. This is one event, and another event is a total of 8. So you have to identify the events very well. You have to identify how many events are there in the question. Here there are two events separated by an or. So I write the two events as A and B. A is the event of getting an even number on the first dice, and B is getting a total of 8. So here you see or is there. So or means union. So you have to find the probability of A union B because it is given as or. If it was given at least one, then also you would have used probability of A union B. So you are to find probability of A union B. Now let us find what are the elements of A. A means getting an even number. There are, on the first dice, there are 3 even numbers when we throw a dice. One is 2, another is 4, another is 6. Now event A will contain, I guess the exhaustive number of cases is always 36. Okay. Now event A will contain 2 on the first dice and with 6 combinations on the second dice. Then 4 on the first dice and 6 combinations for 4 on the first dice. Similarly 6 on the first dice and 6 others on the second dice. So the total number of elements of A is 18. We denote it by M1. M1 equal to 18. Similarly, what will B contain? B means getting a total of 8. So we will write all the elements which sums up to 8. So 2 and 6, the total sum is 8. 6 to 8. 3, 5 also sums to 8. 5, 3 sums to 8. 4 and 4. No more. Only this 5. So the number of elements in B is denoted by M2. We denote it by M2. And M2 is equal to 5. Now you see, compare these two events, event A and event B. There are some elements which are common in both A and B. Let us identify these elements. See, element 2, 6. 2, 6 is there in B also. Then 4 and 4, it's there in B also. 6, 2, it's there in B also. So these 3 elements are common in both A and B. Therefore, A intersection B is the common element. Okay. So number of elements in A intersection B is M3 equal to 3. Now let us use addition theorem, which is given by probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So our target is to find A union B. Let us put the formula. Probability of A is M1 by N. Because the number of elements in A was M1, we declared it as M1. Probability of A is M2 by N. N is the exhaustive cases, and probability of A intersection B is M3 by N. So put the value of all: 18 by 36, 5 by 36, 3 by 36. After adding, we get 20 by 36, which is the probability for A union B. That is the event of a probability of the event A or B. Let us see another example. The probability that a student passes a physics test is 2 by 3, and the probability that he passes both a physics and an English test is 14 by 45. The probability that he passes at least one test is 4 by 5. What is the probability that he passes the English test? So you have to first identify the events. How many events are there? Don't get confused. Just try to identify and or in the question. See here, there is and. And means intersection, of course, and means it is the intersection of two events. Here also at least one. At least one means union. So union of two events. So what are the two events? Physics and English. Therefore the two events must be passing a physics test and passing an English test. So let us write the event as event A. Student passes the physics test, and event B as student passes the English test. And what we are to find? We are to find that he passes the English test. So we are to find the probability of B. Now, what are the given things? Let us write. Probability of A, that is probability that student passes the physics test. It is given as 2 by 3. And probability that he passes both physics and English means probability of A intersection B, which is given as 14 by 45. And at least one means union. So probability of A union B is 4 by 5. Now you use addition theorem. Put everything in the formula. So 4 by 5 equal to 2 by 3 plus probability of B minus 14 by 45. Take B in one side and solve. So you get 4 by 9. You try these 3 assignments and submit to me by Sunday.